All right, welcome to the next video here in this short series that is just, I'm hoping to illuminate, shed a little more light on name mangling in C++ and just some of the behind the scenes stuff, how it works. So in the last video, we talked about a basic function overload. As you can see here, it was utilizing the code that was commented out. This produced one object file, so it was, I guess, a little bit more straightforward in terms of looking a little bit deeper into how the linking process works and resolving which function should, how does it map up essentially this function to the appropriate. In this video, we're going to extend this discussion and add another source file. I'm going to call this simply print.cpp, and just basically all I did was move those two function definitions to another file. And so now in this original program, I have the prototypes declared, or I guess maybe the forward declarations, and then we'll need to essentially, when we compile the program, and let's just go ahead and do that here. What we'll need to do then is we'll need to provide both source files in order to produce one final executable. And so this will then, here, let's actually do this. I'm going to delete all of the .object files and all of the executables just so I don't confuse anything. And we'll run that again. And okay, so now what we do have one executable that is output, but we have two object files, overloading mangling.obj and print.obj. If we let's look at the symbols. So here's our dump bin command symbols for the object file, and you'll see that it looks very similar to what we covered in the last video. That is, here's the mangled name, here is the type that is external, but you'll notice that in this instance now, it doesn't provide a section, and it doesn't provide what amounts to offsets. And so what's essentially it's saying is, I don't know where these symbols are located. Linker, you need to go and figure that out for me. What that can do then, what the linker can do, is it will actually search other object files. And so this is where it can use the actual mangled name to go searching the symbol tables of these other object files. And so helps if you get the right file. Here we now can see that in our symbol table for our print.cpp object file, here are the mangled names. And now here we have the section and the offsets and the fact that it's external as well. So this kind of looks like what the original symbol table looked like from our previous video, in which we just had one source file, one object file. Okay, if we take a look at, let's go ahead, we can disassemble this. You'll see another kind of way in which this works is that right now in this object file, we just have the machine code without these relocations being resolved for the main method. If we look at the same for our other object file, oh, come on. You'll see that it looks kind of similar, but it's kind of, it's also kind of broken up, right? Well, here is just the code we have at the beginning of the text section for this particular object file. We have one of our methods, one of our functions here, as well as the other. And so one of the things that will happen now during this linking stage is that these, sections that have the same name and the same properties will be coalesced together, will be combined together. So that's why if we look at this compiled executable in IDA, we actually will have, it'll look very similar to the previous binary. I'm going to switch modes here to move us into and that if we double click on this sub, it's going to take us to the location where that method is, of course, defined. If we switch modes here by hitting the space bar, you'll see that the beginning of the section begins with main, and now that additional code from those additional object files are just combined later in this particular section. So I don't know offhand the details of how the linker determines to merge the sections. I think it is based off of the order in which those source files are defined. But in this case, you can just see that it is happening. And of course, now the linking is being done appropriately. because if we go back to our disassembly of those object files, right, we have very similar to our previous video, right? We have this call E8, but then these relative displacements are empty. And so it's the linker that not only combines those two, it also updates and produces that, these relocations. And so we can also take a look at that. I'm going to close our 010 editor files. We'll open this back up. So overloading, mangling, and we also have print obj. Right, and then if we look at the print object file, you'll see there are no relocations because there doesn't need to be. This particular object file doesn't require any relocations. It just has to provide, in this case, the symbol table, and there are symbols then for those two functions that we're focusing on. If we look at our overload function, right, here we have a symbol table, right, and we have those symbols, and it's saying, okay, I don't know where these are, right? This is contrary to what we saw in the last video, that the value and the section number are left blank here. They're 0 because they're not defined within the scope of this object file. So they have to be found. The linker has to find those. And then there's really another symbol table that's created during this merging that manages, ultimately then how the linker will be able to update these relocations. And if we look at the relocation entry, it's not really any different. And now these relocations really they're a little bit different. As we saw, main, the code for main now is at the beginning of the text section for the executable. And so these offsets for the virtual address here, they're a little bit different. But if we look at an IDA, we'll see that it at an offset of F. So here is our call. I'm going to switch, there we go, to graph mode so we can see those opcode bytes. This is just how I have IDA set up. At E, so this will be F. Right, and this is what needs to be updated. Symbol table index. So again, it's referring to this first, that's the string table, sorry, to this item. And again, this value and section number indicates that these need to be searched for. And so now the linker can use the name here in order to identify the correct symbol table entry through this new symbol table that it's creating during the merging in order to update those relocation locations and make sure that there's an appropriate, in this case, displacement or whatever the type. We have these different types here, whatever the type may be. So, and then at the end of the day, we get a resulting executable. And because, again, we're just dealing with an executable here, the mangled names, at least in this, like relative to those functions that we were analyzing, they're just not going to be here or appear or be relevant in this particular binary. So when do mangled names show up in executables? Well, let's take a look at one more example in the next video and hopefully shed a little bit more light on our mangled names.